Look up at the night sky. Among those twinkling lights are our planetary neighbors. Two in particular capture our imagination: Mars and Venus. They are the closest planets to Earth, our cosmic next-door companions in this vast solar system. Yet despite their proximity, they are worlds of stunning, almost unbelievable contrast. One is a fiery inferno, shrouded in thick, poisonous clouds. The other is a frozen desert with a whisper-thin atmosphere. This stark difference is a cosmic puzzle, a tale of planetary evolution taking wildly divergent paths from potentially similar beginnings. Understanding these differences is not just an academic exercise, it speaks to our deepest questions about life in the universe. So let us embark on a comparative journey. We will explore the fiery hellscape of Venus and the frigid, rusty plains of Mars. Ultimately, we will ponder which of these celestial bodies, if any, holds the greater promise as a future home for humankind. Let's start with Venus, often called Earth's sister planet due to its similar size and mass. But this sister is far from identical. Venus is shrouded in an incredibly dense atmosphere, about 90 times thicker than Earth's. This atmosphere is overwhelmingly carbon dioxide, a potent greenhouse gas. This CO2 blanket traps heat with ruthless efficiency, leading to surface temperatures hot enough to melt lead. The atmospheric pressure at its surface is crushing, equivalent to what you would experience nearly a kilometer deep in Earth's oceans. The Venusian sky is not blue, but a murky yellowish-orange due to clouds of sulfuric acid. Landing on Venus is an extraordinary challenge for any spacecraft. Probes that have made it have survived only for a short time before succumbing to the extreme heat and pressure. Now let's turn our gaze to Mars, the red planet. Its reddish hue comes from iron oxide or rust in its soil. Mars is much smaller than Earth or Venus, about half Earth's diameter. Its atmosphere is the opposite of Venus's, incredibly thin, less than 1% of Earth's atmospheric pressure. The Martian surface is a desert landscape, rocky, dusty, and marked by craters, vast canyons, and the largest volcano in the solar system, Olympus Mons. Venus presents an environment that is, to put it mildly, hellish. The term runaway greenhouse effect could have been coined for Venus. Imagine Earth's greenhouse effect, which keeps our planet warm enough for life but amplified to an unimaginable degree. Billions of years ago, Venus might have been more Earth-like, possibly with vast oceans of liquid water. However, as the sun grew slightly more luminous, Venus, being closer to our star, began to warm. This warming caused its oceans to evaporate, releasing massive amounts of water vapor, itself a greenhouse gas, into the atmosphere. This created a feedback loop. More water vapor meant more warming, which meant more evaporation, until the oceans boiled away entirely. The consequences of this runaway greenhouse effect are profound. The surface temperature, as we've noted, is uniformly scorching, around 465 degrees Celsius. This extreme heat means that liquid water simply cannot exist on the Venusian surface today. Despite these nightmarish conditions, Venus holds immense scientific interest. Mars, our other neighbor, presents a different set of extremes. It is a cold, desert-like planet, a far cry from the inferno of Venus, but still a formidable environment for life as we know it. Its iconic red color comes from iron oxide or rust, covering its surface, giving it an ancient, weathered look. While Venus is defined by its crushing heat and thick atmosphere, Mars is characterized by its frigid temperatures and an atmosphere so thin it offers little protection from solar and cosmic radiation. The Martian environment, though harsh, holds a certain allure for human exploration, primarily because it is, relatively speaking, less hostile than Venus's surface. The thin air, mostly carbon dioxide, means you couldn't breathe it, and the low pressure would require humans to be in pressurized suits or habitats at all times. Yet Mars whispers of a more hospitable past. Orbiters and rovers have sent back compelling evidence that billions of years ago, Mars was a warmer, wetter planet. This potential for past or present life is a primary driver for our continued exploration of the red planet. Section 5. The Water Saga, tracing a life-giving molecule. Water is the cornerstone of life as we know it. Its presence, past or present, is a key indicator when assessing a planet's potential habitability. On Mars, the story of water is one of dramatic transformation. The evidence is overwhelming. Mars was once a much wetter world. Orbiters have mapped extensive networks of dried-up river valleys, channels, and deltas. Rovers like Curiosity and Perseverance have explored ancient lake beds, finding sedimentary rocks and minerals like clays and hydrated sulfates that form in the presence of liquid water. Today, most of Mars's water is locked up as ice. The polar ice caps are prominent features, composed of both water ice and frozen carbon dioxide, also known as dry ice, which expands and contracts with the seasons. Beneath the surface, particularly at higher latitudes, there is thought to be extensive permafrost, ground ice, that could be a significant resource for future human explorers. Venus, on the other hand, tells a different, more tragic water story. Scientists believe that early Venus may have possessed significant amounts of water, perhaps even oceans comparable to Earth's. The evidence for Venus's watery past is more indirect than on Mars. Today, the Venusian surface is bone dry, and its atmosphere contains only trace amounts of water vapor. Section 6. New Worlds, New Homes, the Colonization Conundrum. The dream of establishing human colonies on other planets is a powerful one, but the practical challenges are immense, especially when considering Mars and Venus. For Venus, the surface is simply out of the question for any foreseeable colonization effort. The extreme temperatures would vaporize most materials, the crushing pressure would obliterate any conventional structure, and the corrosive sulfuric acid atmosphere would eat away at anything left. However, an intriguing, albeit highly speculative concept for Venus involves floating cities. At an altitude of about 50 to 60 kilometers in the Venusian atmosphere, the temperature and pressure are surprisingly Earth-like. Mars, while still incredibly hostile, presents a more grounded set of challenges for colonization. The primary hurdles include the extremely thin atmosphere, which offers little protection from solar and cosmic radiation and means humans must live in pressurized habitats. The cold temperatures require robust heating systems. Establishing a self-sustaining colony on Mars would require breakthroughs in habitat construction, life support systems, agriculture in controlled environments, and radiation shielding. Section 7. The Next Giant Leaps. Future Exploration Unveiled. The exploration of both Mars and Venus is set to continue with a new wave of ambitious missions from space agencies around the world. For Venus, after a period of relative neglect compared to Mars, there's a resurgence of interest. NASA is leading the charge with two recently selected Discovery Program missions, DAVINCI Plus and VERITAS. DAVINCI Plus will send a probe through the Venusian atmosphere, analyzing its composition and even attempting to take pictures of the surface on its way down. VERITAS, on the other hand, will be an orbiter, equipped with advanced radar and spectroscopic instruments to map Venus's surface in high resolution, study its geology, and look for evidence of active volcanism and plate tectonics. Mars, of course, remains a prime focus for robotic and future human exploration. NASA's Perseverance Rover continues its search for signs of ancient microbial life in Jezero Crater and is collecting samples for a potential Mars sample return mission. Furthermore, NASA's Artemis program, focused on returning humans to the Moon, is explicitly framed as a stepping stone to prepare for human missions to Mars. Private companies, most notably SpaceX with its Starship program, are also developing capabilities with the explicit long-term goal of enabling human settlement on Mars. The coming decades promise a flurry of activity, pushing the boundaries of our knowledge and our presence in the solar system. Section 8. Are we alone? The search for life beyond Earth. The question of whether life exists or ever existed beyond Earth is one of the most profound inquiries in science and philosophy. Mars and Venus, our closest planetary neighbors, are natural laboratories for exploring this question within our own solar system. For Mars, the evidence of a past warmer and wetter environment makes it a compelling target. If life did arise on early Mars, when conditions were more clement, it might have left behind biosignatures, chemical, mineralogical, or morphological traces in ancient rocks or sediments. Venus presents a more challenging yet intriguing case for astrobiology. Its surface is undeniably too hostile for life as we know it. However, as mentioned earlier, a region in its atmosphere about 50 to 65 kilometers up offers more temperate conditions. Section 9. Our future off-world, weighing the planetary candidates. After journeying through Venus and Mars, which planet holds more promise for future human life? The choice leans heavily towards Mars. The Martian environment is less extreme than Venus. Accessing water ice, utilizing atmospheric carbon dioxide, and large-scale habitat construction make Mars a tangible target. Venus, with its extreme conditions, is not viable. Mars offers a solid surface, though challenging. Engineers believe these challenges can be overcome. Water ice is essential for life support and fuel. The red planet beckons with a clearer path forward.